All right. So we are saying that because we are engineers, our length, we normally do our calculation in what? Millimeters. Okay. Yes, because of the iron rods we use and all that. So the question that is saying that a rod 150 centimeter long. So you can see that I've stated all these parameters down. Okay. First of all, you have to analyze the question even before you start to go to your given to solve. Okay. It's just like you want to say something. You have to think before you talk. You don't just talk. You understand me? So analyze the question. So analyzing the question is part of what I'm doing on the question paper. Let's say this is my question paper now. Okay. So you having a pen, so you try to analyze the question here first, even before you move to the given, because once your given is affected, there is a high possibility that your question may also be affected. Try and understand the question very well. Okay. Okay. So the question is saying that a rod 150 centimeter long. So a rod 150 centimeters. Okay. Long. So because we said that we don't want to do our calculation in centimeters and we want to do them in millimeters, the 150, if we want to convert it to centimeters, what do you think is going to be? Okay, let's go back to whatever we learned from the other day. Now we want to convert what? Centimeters to what? Millimeters. Okay, good. So the rule is hot, 10 hot, 10 millimeters is equal to 1 centimeters. Okay, so if we are supposed to convert what? 150 centimeters to what? Millimeters, what do you think is going to be? It's just a matter of cross multiplication, right?
Yes.
So what do you think our answer is straight away from here? You realize that this is
1,100.
what? 1,500 millimeters. Don't rush at all. Just take time. There is no hurry in life. So that is 1,500 millimeters. Analyze the question very well. Two, end of diameter 2.0 centimeters. That is if you consider like this, the rod over here. The length of the rod is what they just gave us. So you realize that the rod, this part of the rod is round like this. Okay. And this part of the rod is also round toward the other end. So it surely has a diameter. And the diameter is the D that I'm writing in it now. That is the diameter. And from here, the overall length of the rod. From here to the overall of the of wood. So that is what we are saying 1,500. Okay. So the D, they say it is 2.0 centimeters. So from whatever rule we establish over here, let's go back to the rule we established. This time we are converting 2.0 to the other way around. So you realize that it's just a matter of multiplication. So this is 2.0. If you multiply 2.0 by 10, what are you going to get? 20 millimeters, right? So now that is going to be what? 2.0 centimeters is equal to 20 millimeters. Yes. Okay. To an axial pull of 20 kilonewton. So that is the P over here. And the P is our force. I told you force is measured Newton. And the K is a prefix. Okay. To avoid writing so many zeros, that is why the K was put over there. It's a language of physics. Make life much more easier. So that is, this can now be written as what? 20 kilonewton. But in actual sense,
So 20,000 Newton.
yes, it's actually 20,000 newton. So I can write 20 times 10 exponent 3. It's the same thing. Newton. Good. If the modulus of elasticity of the material of the rod is 2 times 10 exponent 5 Newton per millimeter squared. So now they say we should determine some people. But first of all, let me write the important points down. Okay, I'm actually just trying to pick out whatever formulas you want to derive some. I'm actually just trying to bring those formulas. You find them. Do you understand me? So there's going to be a lot of change that's going to be going on. Good. So over here, our E was given to us as 2 times 10 exponent 5. You see, and that is the mode of the Newton per millimeter squared. So now what is happening? They say stress. We don't know the stress. It was not given to us. So question mark. The strain, we don't also know question mark. And the elongation, it was not given to us. Question mark. You see what is happening over here? So now that I'm done analyzing the question, I can just go and start solving somewhere. You see, we go to our question paper and just start straight from our then we proceed. Good. We go to our answer booklet, then we start from our given. As part of the analyzation of, is there any question someone wish to ask before we proceed? Any question, any contribution, anyone wishes?
So I have a question, a quick one. Just like you taught us the song the last time. With this particular one, can you now say that so that you are able to remember quickly, you can arrange them as plain, PLA. No, there's no N here. Hey. So
Okay.
I see PLA and then E, then change in length, then the strain symbol and then the stress symbol. So I don't know, just for the sake of clarity, so that you
Okay.
don't miss out certain. I'm
Okay.
just saying.
Okay. I understand you perfectly. The reason why I was writing this way is that let's come and read the question again. A rod 150 centimeter long. So the first person to put over here was who? Length. Can you see?
Right.
Of diameter. Centimeter. So the second person I met when I was reading
It's
the
a diameter. Mm.
is subjected to an axial pull of 20 kilonewtons. That was the third person I met on the road.
Right.
How quantity so?
Well understood. Well understood.
So that is how you have to pick it, okay, so that you don't confuse yourself. Because the way
Okay. Okay.
that's how you have to write the given. If you don't take time to write it in that way, at the end of the day, you may confuse yourself. If you want to be forming song for this, you just understand that is part for you. But the
Yeah.
important ones, you can form song for them. Why not? Because you will make it. But for questions, let's just be flexible with them, and then life is going to be much more easier. Okay. So let's.
Easier. Yeah. Thank you.
Dennis has a question.
Yeah, this is John. Yeah,
Good
so
evening, engineer.
hello, can you hear me?
Yes, Mr. Ayn.
Yeah. Sir, I have a question.
All right, I'm listening, please.
Yeah, so it's like a layman asking a question. So don't be offended. Now, the rod. What are we calculating the rod for? I know we are calculating for the strain, and the elongation, but to, let's say, a lay person. Now, are we calculating this one to know whether there has been an extension, whether there has been a reduction, or what are we calculating the rod for?
Okay. Before I answer your
So
question related to real, and later I come back to this. Okay, good. You see that tomorrow is Sunday, but if we
Yeah,
tomorrow, you will realize that some people are going to actually be sleeping in church. If you ask them, they'll say that they are tired, they are stressed, they are depressed. A level of that, it can be calculated for. Do you know that? Uh-huh.
okay.
Stress that is actually letting them sleep. You can calculate for that. Yes. In the same way, if we drive that to here, you realize that it is the same thing. Okay. Now you have a building, but you realize that uh, the building that you saw somewhere, the cracks have started developing somewhere, and even you are afraid that, hey, this building there, if they don't do something about it, in few days it can fall down. That is even a layman. Oh. Uh-huh.
Yeah,
In the building is as a result of what? Stress, and it is the result of too much load that is put on that material that is causing it to what? Stress that way. The person that is sleeping in the church, he or she is sleeping in the church because maybe there is so much force on the person. That is why he's not able to what? Sleep at night. He has a lot of work to do. You see, or the person was watching movie, he was busy doing something else. You see, so in the course of that, he was actually putting force on his brain. Now, at the end of
Okay.
the brain is stressed in the chest room, he can't do anything else but to sleep. See what is happening over here. So it can be
Okay.
calculated for, and we at the end of the day, we are going to find out that it's because of this and this and this. That is why this person is sleeping in church. Now, that building that has developed crack, if we want to know the level of stress that is causing the building to crack, we can calculate for it. Okay, provided you know the hot area of the beam. Okay, and also the area of the beam, and also the force that is acting on it. Do you understand me? That is.
Okay.
So this beam over here, the force can be this. Let's say this is just a rod, oh, but if you have a beam, you can have a beam that at the end of the day, you realize that the beam is being acted upon by a number of forces. Very soon, don't worry, we are going to start meeting most of such questions, and you realize that life is going to be much more easier. Okay, so such a beam like this can have a point load on it that is P, and you realize that at the end of the day, that load on it can cause it to deflect. If you really want to understand deflection, that is the question you're asking me. I have a lecture video on that on my YouTube channel. Do well to watch that video, and you realize that you're going to become more history than you can ever imagine.
Okay.
Are you okay with your question, or you wish I
Yes,
should?
I'm okay. I'm okay.
Okay. So the strain, that is the what? Change in length over original length. Iron rods, in normal cases, if let's say at the end of the day, the strain. Now let me explain the strain to you. If let's say there is a particular knicker you used to wear, you realize that with time the knicker, like the way it used to tight you first, now it doesn't tight you that way again. Okay, especially
Yeah.
dresses and elastic knickers we used to wear. You see, or let me say first, when you bought a rubber band, you realize that first when you fix it on your hand, you have to stretch it well before it actually enters your hand. But with time, it got so loose that even if you put it on your hand, it falls back. Okay, that is happening because what? It has strained. Okay, it has strained. It
Okay.
length. There have been a displacement that they have. You understand what I'm saying?
Yeah.
So that is occurring in that. Let me say rubber band. That is why at the end of the day, if you put it in your hand, it is still falling back. So if you want to know the strain in the rubber band, what are we going to do? We are going to take the original length of the rubber band over the hot. We are going to take the original length of the rubber band and write it down. And come and also now calculate final length of the rubber band. That is the change in length. Okay. So finally, to calculate,
Okay.
we are going to divide the hot change in length over the original length. We are going to know the strain that is in hot. Your rubber band that is causing it to fall. You see, so this is just practical. We can relate it to real life, and life become much.
Amazing. Amazing.
So this rod over here, if at the end of the day it is subjected to tension, if someone pull this side, or let me say you apply some two forces to it, one force pull it to this side, the one force also pull it to this. At the end of the day, this iron rod, it is going to strain. Do you understand me? If you over pull this iron rod, the diameter is going to shorten. Okay. So at the end of the day,
Mm.
it's also even going to increase. Do you understand me? So such a rod can now be called a strain rod. Meanwhile, it is just the same rod, though. But because it was subjected to too much force, you realize that it has strained. Okay. Once it's strained, but you know that this thing it has lost its original strength. You see.
So
So
elongation has taken place.
thank you. So if this was the original length initially, you realize that some has come to add. Okay. Some have come to add to it. So this is actually the additional length that have been added to it. So you see the change in length that has been added to it. Initially this was a long, so that is it. Okay, let's quickly open to a fresh page and let's begin our calculation. Okay, so this was our given. So quickly mention some of the parameters we were writing out there to me, and then we go. So let's say our question one will LDPE. So let's all write that LD. Also, we had a stress strain and change. Strain. Exactly. Anyway, how many were able to watch the lecture videos after the class the other day? How many of us were able to visit the lecture videos to watch them after the class the other day?
Yeah, I did.
Okay, that's good. So remember to subscribe to the YouTube channel so that anytime I release any important or relevant video over there, you can receive them in case I forget to send you the link. Okay, so our length that was given to us was 150 centimeters, but we later converted it to 1,500 millimeters, which is the same as our length. Okay. Also, our diameter that was given
Diameter.
centimeters. We later did our convention and realized that it was now equal to 20 millimeters. And we said that this is known as our diameter. The P is our load. And then it was given as 20 kilonewton. 20 kilonewton. Which we later express as 20 times 10 exponent 3, okay, Newton, which we said that this P is actually our hot force, okay, force or load. It is all the same thing. In some cases, they will say load, don't get confused. I'm just taking my time because I want you to really understand everything. That is why I'm taking my time to explain every bit of information. Good. So this is our elasticity, and the elasticity given to us in the question was actually what? 2 times 10 exponent 5. You realize that currently there is no preface for that. Maybe someone can make an experiment to discover that to make life much more easier in the future. So because there is no preface for this currently at the moment, we are still writing it as 10 exponent 5. But if there was, we would have just placed a symbol over there and life is still easier. Good. So that is Newton per millimeter squared. So that was our modulus of elasticity. Modulus of elasticity. That was the modulus of elasticity. Modulus of elasticity. Modulus of elasticity. Good. So our stress was what? Unknown. Also, our strain is unknown. Our change in length, elongation or extension, or even displacement is also an unknown. So these are actually the people they want us to find. This now become our question A, question B, question C. Okay. So this is now our question what? A. They're asking us to find. This is question B. They're asking us to find. And this is our question C. They're asking us to find. You see, as it has been denoted nicely. Now we can come to our solution and we begin to solve. So let's quickly move to the solution. So before that, if you still wish to add some diagram to attract more mark, take note, addition of diagram to your given also attracts more marks. Okay, so from whatever question we read, we can just try to put a diagram, okay, to attract more mark, to attract more marks. So they say a rod 150 centimeter long. I'm going to pull the 1,500 over here. This time I want to work like an engineer. So 1,500 millimeter. So this is the total length of the rod. That is it. Is subjected to what? An axial pull. We say force is a pull or a push of an object. So once it's an axial pull, axial no so it's a namna pempemu direct. So it is subjected to an axial pull. You see, so this is one P over here, pulling it. This is also another P over here, pulling it. This guy is in tension, serious one. It's subjected to an axial pull of what? 20 kilonewton. Okay. It's subjected to an axial pull of 20 kilonewton. So you there, to avoid confusing you, let me use my numbers. So when you see the symbol, you know that, oh, okay, he's the one. So that is 20 kilonewton. 20 times 10 exponent 3. 20 times 10 exponent 3 Newton. That was actually the pull on it. Okay. If the modulus of elasticity of the material, now the E of the material, that every material has EO. Okay. And this is the number of what stress the material can withstand. Okay, before failure. Do you understand me? So that is the modulus of elasticity giving us 2 times 10 exponent 5 Newton. Or I should have even written that inside the material, so that at the end of the day, we can all see what is happening. That is that of the material. So let me change color pen, and I'm going to write it in the material. So you see, E is equal to, let's say, 2 times 10 exponent 5 Newton per millimeter squared. There may be a high possibility that the video, I may not send it to you. Something may happen. Okay. So if you fail to write, and at the end of the day, I refuse to send you the video, then you realize that you still lose important informations. That is why I urge each and everybody to be able to take a pen and a paper and write down important points. Thank you very much. Also, as we are done putting down our diagram, we can begin to proceed. All of this attract mark. They give in the that's why I always say you can never fail strength of material, because at least if you don't know anything, you should be able to write the given. Okay, so let's proceed. So we are coming to our solution. So this becomes our solution. And the first person that we were asked to find for is the stress.
Stress.
We already read so many formulas for stress, so don't worry. In the examination, well, once you're able to remember Hooke's law, life should be much more easier. So I'll urge each and every one of us to be able to state the Hooke's law. Okay, they say we should find for our stress. Good. We know that what our stress is equal to what? What was the formula for stress? But before that, let me just use 2 pages so that life can be much more. Okay. So what was the formula for the stress? I just came back here. What did we say is the formula for the stress? Stress. If you want to find for stress,
As the force over area.
Someone said
Force per area.
force over area. So let's write. We said stress is equal to
Force over area.
area.
Force over area. Yes.
Also, give me another formula for stress. So this is one formula for stress. I want another formula again. Let's try and have all the formulas that we can use to calculate for stress, even before we proceed.
Yes, stress is equal to strain over elongation.
Hello?
Yeah, stress is equal to strain over elongation.
Okay. You said stress is equal to
Strain over elongation.
can you see this formula over here? The formula I showed you, I derived this formula for you some few minutes ago. Okay, Bernard Asari wants to talk. Bernard Asari, Please, can you throw more light?
Please, the stress is elasticity times strain.
Exactly. For recording purposes, I respect each and everyone's privacy. Okay. So sometimes you need to understand some behaviors. All right. So that you are right. That is stress is equal to elasticity times strain. Okay. As simple as that. That is why we first of all I try to derive the formula together with you. Okay. So that at the end of the day you can see how it is. You can play with it. So that even if you forget the formula, you can just play with the law and you realize that, oh, you actually discover all of them. Okay. This is actually strain I'm supposed to write. Okay, so these are the two formulas we have for stress. Okay, so good. Let's see which of them can be used to solve our work, and then life becomes much more easier. You realize that the first formula that we took, do we know the P in the given? Can we find P in the given?
What is the force?
Can we find, yes, can we find the force in the given?
Yes.
Axial pull. Axial pull.
Okay,
Yes, we can.
okay,
And it's 20 times 10 kilonewton.
okay. Let me quickly write this as axial pull. Good. So we have the P in the question, that is 20 kilonewton. Also, the area is unknown, but the area can be calculated for. The formula for our area in this case is equal to what? We are going to be using pi d squared over 4. But take note, area can be calculated for in so many ways. Area can be calculated for in so many ways, and I'm going to list that for you now, for you to see. So, but what about the other formula? If we want to use the other formula, you realize that if, but, and we don't know the strain, and they are even asking us to they are also asking us to calculate for the strain over here. So if that is the case, then it means that let's adopt the first formula. If that is the case, let's adopt the first formula. So that is how we are going to be applying the rules, and we are adopting this. So we are actually adopting stress is equal to E over A. So this becomes the formula we have adopted to solve our question. Now we can proceed. Okay. So from here we say that the P is known, but the A is unknown. So the A, I'm going to put question mark over here, but the P, we say the P is equal to 20 kilonewton. That is 20 times 10 exponent 3 Newton. How do we calculate for the A? So I'm going to say that what? But A is equal to area. So but, okay, let me put it over here. But A is equal to, let's say, pi d squared all over what? 4. Okay. Also, take note. Also, comma, A is equal to what? Pi r squared. Pi r squared. Someone will say that if our length is a rod we are using, and if it's a rod we are using, the rod has a length, why can't we just multiply length times breadth or something? Take note that the rod okay, has a circular part. If you look at here, this rod over here, it has a circular part. This is it over here. Okay. So due to that circular part it's having, to calculate for the area, we have to use that diameter. And that is why at the end of the day, we are coming out with these formulas. Okay. You can either use this to calculate for your area, or you can either use this to calculate for your area. Okay. Yes. The area also has a different formula. Okay. But you have to know the one you're supposed to use at the right time. Okay. Let me quickly add the last one for you. So I said that what? And what? Also the A is equal to what? Pi d t. That is the pi times the diameter times the what? Thickness. Okay. Take this or jot these things down. Take these things very, very, very serious. Take some of these things very, very, very serious. Okay. But for in this case, I will just choose to use one and then we proceed. Okay. So let's adopt the first one that I pick. Let's adopt the first one that I pick. So if you want to calculate for our A, how are we going to calculate for our A for? So we said that if our A is equal to what? If A is equal to pi d squared over 4, so our A is equal to pi d squared over 4. Okay. In this case, our pi that we are going to consider is what? 3.142. So this is it. Let's say 3.142. Okay. And the value of pi is just 22/7. The value of pi is 22/7. You can try that somewhere and you realize that you are going to get the same answer I'm talking about. That is 22/7. Okay. From an experiment, this was acquired. Okay. So times what? D. And our diameter we're going to be using in this case is the diameter that was given in the question. What was the value of our diameter? We said the diameter we're using is 20 millimeters. You see. So let's quickly.
20.
So that is, here is going to be 20 all squared. But take note, for safety reasons, let's work with the units. This is millimeters all squared. So now I can bring the 4. Okay. Now I can bring the 4. So finally, what do you think is going to happen? If you punch this on the calculator, can we all quickly punch this on the calculator and tell me the answer? Quickly punch this on the calculator and tell me the answer. So if you punch this on the calculator, I realize that finally our area, I just punch this and I'm getting 3 points. Or let me say I'm getting 314.2 millimeter squared. Millimeter squared because this 2 over here is going to affect these millimeters also. Okay. So at the end of the day, we are going to get 314.2 millimeter squared. We are done calculating for our stress. That is it. So our stress, we say our stress was equal to 20 times 10 exponent 3 Newton all over what? 314.2 millimeter squared. Someone should quickly punch this on a calculator for me and tell me the answer. So finally, what do you think our answer is going to be? Anyone with the answer?
63.654.
So you said you had 63.654. Okay, so
63.
63.
Yes.
654. Have to add a unit. Unit. Any other person with a different answer? Anybody with a different answer? Okay, so I think she was right. She just converted the 7 to 1 to add to the 3. That is why she's getting the 4 by. Don't be confused when you also punch and get the same. So we are done with section A. Okay. So let's quickly now go and solve for B. Let's quickly now solve for B. The B is asking us to calculate for our strain. So let's solve B on this page. This is our B. From the formulas we derive, what did we say are some possible formulas of strain? We said that the strain is equal to what? First of all, we say it's equal to change in length over what? This is one formula. Also, what is the other formula for strain? What is the other formula for strain? From all the formulas we have been deriving so far, let's quickly see if we can see the formula for strain. What is the formula for strain? You see over here, equation 3. Can you see equation 3? Strain is equal to what? Our stress over what? Elasticity. Can you see that? Good. So this is the formula over here I'm talking about, stress over elasticity. So let's quickly put that down. Our strain. So our strain is equal to stress over elasticity. Stress over elasticity. So this over here, let's not get confused. This is the strain. Okay. So if you want to use the first formula, it will not work, because at the end of the day, you realize that even the elongation, they are telling us to find the elongation. We also don't know the strain. These two people, they are unknown. So this will not work in this case, but this is going to what? Work. You see, that is why you always have to be able to know all the formulas before you know which one to pick. So finally, we can say that our strain is equal to what? Stress over elasticity. This is the formula you want to adopt. Okay, let's quickly do our substitution and let's go. So our stress, what is the answer we had for the stress? We had
63.654.
0.654. Okay, good. That is Newton per millimeter. Newton per meter squared. And then this one too was given to us as, what was the value of our elasticity? 2 times 10 exponent 5. So 2 times 5 millimeter squared. Newton per millimeter squared. So the units are going to cancel each other. That is why strain has no units. You see what is happening over here. So this is going to cancel this. At the end of the day, strain is going to be alone. So what is going to be the answer for strain? What is going to be the answer for strain? After point